ceramic cardboard box. The paper that we start with has dimensions of 22 by 18. The number one thing we got to remember about this is when we take these dimensions, (18 and 22), you're cutting little boxes out of the corners, which means you're cutting X on both sides. You're cutting it on the top and the bottom and the left and the right. So inside these dimensions here, this would be 22 minus 2x. And this dimension here would be 18 minus 2x. And then the height of the box is going to be that x that you cut in. And that's actually our equation for volume. So our volume, V of x, 22 minus 2x, 18 minus 2x. And then our height is just x. And determine the domain. Domain is the x values. For x, the farthest we can cut into the box is halfway, because then you start cutting out of the box. You can only cut in half. So you look at the smaller of these two dimensions, the 18, because that's going to be the smaller amount that you can cut. You can only cut halfway. So it's got to be less than 9, less than half of 18. So our domain has to be positive, so we can start at 0. And it can only go up to 9. Neither of those endpoints are allowed, though, so it's parentheses on both. You have to cut something, and you can't cut the full 9. So otherwise, the strip just falls off. You want the volume of the box to be 500. What are the possible values? So we've got our equation. We know what we want it to equal. We're going to solve that. The easiest way to solve that is on your calculator. So we type it into our graph. We can hit graph, but we got to set up our window. So go V window. We just said our domain for this function is 0 to 9. So that's going to be our x values, 0 to 9. Our y values, if you just read the problem a little bit, it's going to tell us that we want the volume to be 500, so we know the volume is going to go higher than that. Pick something higher than 500. You can always make it larger if you want to. I'm going to say 1,000 just as a guess. Probably good enough. You can also do zoom auto, and it will adjust your y's for you once you set your x's. You got to set x first. So we want the volume to be 500, so we go gsolve. That's the y equals 500, so that's an x calc when y is 500. We get two values, 1.968 and 4.7996, so 4.8. What are the possible dimensions? So the 1.968 would be like your height, but we got to do 22 minus 2x and 18 minus 2x to get our length and width. I think I have x saved from the calculator, or from the graph, it's saved as that one. So 22 minus 2x, 18.064. Minus 2x, 14.064. And then our x value right there was the 1.968. That's one of them. These are all in inches. Make sure you label it. The other one we're using 4.8. So 22 minus 2 times 4.8. It's 12.4. And then 18 minus that. It's 8.4. So there's your dimensions for the 2 ways you can make the box. And the last question is, what is the maximum volume? Go back to the graph. Maximum volume, GSolve max. We're just trying to find that right there. GSolve max. X would be what we're cutting. The volume is the 579 number. 359. And that's volume, so that's going to be inches cubed.